Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we will be doing checkpoint 5.20 from section 5.5, the alternating series test. It says to determine whether the series, this is a series, the sum as n goes from 1 to infinity of negative 1 to the n plus 1 times n, and divide the whole thing by 2n cubed plus 1. We want to check if that converges absolutely, converges conditionally, or diverges. So the first step is to take the absolute value of that and then check if that series actually converges absolutely. And if it does, we're done, we move on. If it does not converge absolutely, the next thing we need to check is to check if it converges conditionally. With that, we need to put this series through the alternating series test, which has to satisfy two conditions. The b sub n term has to be decreasing, and the limit as the b sub n term goes to, as n goes to infinity of the b sub n term has to equal to 0. So if it satisfies those while not absolutely converging, we can conclude that it would converge conditionally. Now, if it doesn't converge absolutely and it doesn't converge conditionally, then it must diverge. So that's going to be the process. All right, so we will check for absolute convergence, and if it converges, we'll be done. If not, we'll check for conditional convergence. So check for absolute convergence. We take the absolute value of this whole thing, which is essentially getting rid of the negative 1 to the n. So I'll write that out. This is the absolute value of negative 1 to the n plus 1 times, I'm going to write n over 2n cubed plus 1 separately here to just say, well, when we take the absolute value of this, the n over 3 over 2n cubed plus 1 will always be positive because we're going to put in positive numbers for n, and so the absolute value of that is just that term. And we don't need the absolute value here at this point anymore because for all the n's that we're going to put in, those are n values that are from 1 to infinity. This term or this expression will always be positive. All right, now we want to check what's happening here. This is the n over 2n cubed plus 1. We're going to look at this as a series, and I'm going to skip over the subscripts here. And how we're going to check this. We want to compare this, compare with 1 over 2n squared, or we can compare it with 2 on the outside and then 1 over n squared. Or let's throw 1/2 here because the 2 has to be in the denominator. So essentially what I'm doing is I'm using a comparison test to check if the absolute value of this expression is going to converge. Now I hope it's going to converge because this is a p-series, and we know that this p-series converges because the p is bigger than 1. So we know from the p-series that if the p is bigger than 1, it's going to converge. And multiplying this by 1/2 is not going to do anything in terms of its convergence and divergence. Okay, so what tests are we going to use? It's a comparison test. We can use a regular comparison test, or I guess I'll use a limit comparison test. So to check this, we're going to use a limit comparison test. And we want to take the limit as n goes off to infinity, and we just take the ratio of this. So this is 1 divided, or n divided by 2n cubed plus 1 over, I'm going to put the 1/2 out here. Well, let's put the 1/2 here, and then 1 over n squared. I suppose that 1/2 will make this 1 over 2n squared. Maybe that'll be easier to work with. All right, so we take the limit as n goes off to infinity, and we have n divided by 2n cubed plus 1 times 2n cubed. And this is going to equal to, oh, this is n squared, sorry. This will equal to limit as n approaches infinity of, this is 2n cubed divided by 2n cubed plus 1. When we're doing these limits, we can just, if we have the degree of the polynomial in the numerator to be the same as the degree of the polynomial in the denominator, then the limit is simply going to be the coefficients over each other. Another way you can do this is you can divide both the top and the bottom by 1 over n cubed, and then we'll see something going to 0. Either way you look at it, this is going to equal to 1, which is not infinity or not 0. So this conclusion says that since the series, the p series 1 over n squared converges, and we got the limit to be equal to 1, then we can conclude that the series n over 2n cubed plus 1 also converges. All right, so now that we know that, we know that the absolute value n over 2n cubed plus 1 converges. Therefore, we can conclude that the alternating series, negative 1 to the n plus 1 times n over 2n cubed plus 1, this is going from 1 to infinity, we can actually conclude that it absolutely converges. Okay, and that's our result. So I hope that helps. Good luck.